Good morning, guys. Am I audible to all of you?
Yes, sir. Yes, sir. You are audible.
My screen is
Good
also
morning.
visible to
Yeah.
all of you. Morning. My
Yes,
screen.
visible.
Okay.
Visible.
Yeah. Guys, guys, I just need to tell you one thing that whenever I'm explaining the concept now, I'm going to explain you the concept. I'm going to give you one real-time example how to use those concepts, right? Further things you need to do some kind of R&Ds, right? R&Ds in the sense you need to check you just need to search the same thing on the internet, right? You will get multiple websites. They are giving different types of examples. Just go through the examples, right? It's not possible for me to give multiple real-time example for a particular concept in the session. Why I'm asking? Because see, I targeted that chapter three classes, that events and a delegate, but that took approximately 5 classes, right? If in this way we are proceeding, then the course is not going to be completed in 5 months, right? So it will be take 1 year to complete the course, but we have to complete this in 5 to maximum 6 months, right? So I'm going to explain you the concept in detail. I'm going to give you some real-time example, but for more real-time example, you have to search it on internet. You will get many different kind of real-time example from different websites, right? Right, but anything related to concept, definitely whatever I'm going to explain you can easily understand, right? Code you can easily understand by looking at the code of different applications provided by different websites. You can easily understand. There is, you should not get any kind of confusion. That guarantee I can give. Right, because see, if I'm going to explain each concept to it three, four different kind of example, that means the course duration is going to be double. Right, but we have to complete this course in 5 to 6 months. Already we have completed 2 months. Okay. So today and in our few upcoming sessions, we are going to start the most important concept you can also consider, that is multi-threading. So as a developer, as a whether you are a student or whether you are a fresher, whether you are a beginner level developer or whether you are having experience, right? You should understand what is multi-threading, right? Until and unless you are not understanding multi-threading, you cannot develop better application in the sense, from the performance point of view, you cannot develop a better application, right? So in today and in our few upcoming sessions, I'm going to discuss all about multi-threading, and I'm sure at the end of multi-threading you will have a very good experience of how to develop a better application by implementing the concept multi-threading, how you can improve your overall performance of the application, how you can utilize the CPU resources effectively, right? Why we should go for multi-threaded application, everything we are going to discuss as part of this course, right? So if you look at the syllabus, right, so I think I have created 21 chapters, right? So you can, today I'm going to give you the introduction, what exactly multi-threading and all these things, but you can see there are 20 chapters. So we are going to discuss what is the thread class, how to pass data to a thread function in a type shape manner, what is type shape, right? How to retrieve data from a thread shape function, what is each elif and a join method, right? Each elif property and a join method, what is thread synchronization, why it is important to understand thread synchronization, how we can implement thread synchronization using locking, monitor, mutex, semaphore, and a semaphore slim class, right? Then we will discuss what is the concept of a deadlock, right? You might be heard deadlock in SQL, right? But the same concept is also available in deadlock. How we can achieve deadlock and how we can avoid a deadlock in C sharp, right? Then I will show you the performance testing of multi-threaded application. I will give you one example where I will show you without multi-threaded how much time that with multi-threaded, what is the time duration, right? So that I'm going to explain you. Then I'm going to discuss, there is a concept called a thread pooling. There is a concept called a foreground and background threads, right? That I'm going to discuss. Then we'll discuss what is auto reset event and manual reset event. We'll discuss once you understand the thread concept, then we'll proceed and try to understand the thread life cycle, right? Different state of a thread priorities. If you are having multiple thread, then how you can set the priority of a thread, then how to terminate a thread. Suppose one thread is, you created that thread executing one method, and at some point of time you want to terminate that thread, then how inter-thread communication is happening. One thread wants to give a signal to other thread to start the execution, how. And finally we'll discuss how to debug a multi-threaded application, because if it is a single threaded application, the execution takes place sequentially, so you can debug that in a normal manner. But if it is a multi-threaded application, multiple threads are going to be executed at the same time, right? Then how you can debug the same thing, right? That what I'm going to discuss. So, yeah, it's actually going to take more than 5 to 7 classes, right? 5 to 7 classes to complete all these things. Today, I'm going to give you a brief introduction to multi-threading, all about multi-threading, what is multi-threading, right? What is single thread application? What is the problem with single thread application, right? Uh, how the how exactly an application is executed by operating system, right? How we can overcome the single threaded problem in our application. All these things we are going to cover today. And from tomorrow onwards, we are going to start the thread class, right? So, so today we are going to discuss what is multitasking. How does the operating system execute multiple applications at a time? What is a thread? Understanding the thread class in .NET Framework. What are the drawbacks of single-threaded application, and how to overcome the drawback of single-threaded application using multi-threading. That is what we are going to discuss today. Okay, so before understanding multi-threading, let us first understand what is multitasking. If I ask you this question, what is multitasking, then what will be your answer? Any guess from anyone?
Doing several tasks at the same time.
Exactly. So during several tasks means you are one person. At the same time, you can listen music. At the same time, you can write something, right? At the same time, you might be taking some tea, right? That means what? You are only one person, and you are performing multiple tasks simultaneously, and this is nothing but multitasking, right? So multitasking means what? Multitasking means performing multiple tasks at the same time. If you take the example of operating system, right? Operating system is a multitasking operating system or not? Yes, it is a it is a multitasking operating system. Why? Now it has the ability, right? It has the ability to run multiple applications at the same time. Currently, you can see I'm opening my notepad. Currently, I'm using Zoom, right? Currently, I'm using Visual Studio. Currently, I'm opening in a Windows, sorry, Google Chrome browser, right? At the same time, I'm also opening some Windows Explorer. That means even I can also open Notepad at the same time, right? That means I'm performing multiple tasks at the same time on Windows operating system. So I can say Windows operating system is a multitasking operating system, or other word you can say, as you are performing, as you are operating with multiple applications at the same time using Windows operating system. So Windows operating system is a multitasking operating system, right? Now the important question that you need to understand how the operating system execute multiple applications at a time, right? That is fine. We can see, right? As a user of our computer, we can open Google Chrome browser, we can open MS Word, we can open a Notepad, we can open Visual Studio, we can open VLC Media Player, Windows Media Player, right? Anything we can open at the same time. But how operating system going to execute all these things at a time? That what we need to understand, right? So say to execute all those applications, operating system makes use of something called processes, right? So operating system makes use of something called processes. What it means, now for to run Google Chrome browser on your machine, it will make use of one process. To work with Microsoft Word document, it will make use of one process. To work with Notepad, it will make use of one process. Similarly, for each and every application that you try to run or you try to open on your Windows operating system, internally operating system going to make use of something called processes, right? Then what is a process? Now, a process is a part of the operating system, or you can say a component under the operating system, which is responsible for executing the program or application. So to execute each and every program or application, there will be a process, right? So what, see, operating system makes use of processes to run multiple program or applications simultaneously. Then what is process? Process means it is a part of the operating system, or you can say it is a component of the operating system, and operating system make use of this process or make use of this unit, right, to run the application, right? That means to run each and every application, there will be independent process. One process will be there to run Google Chrome browser. One process is there to run Microsoft Word document. One process is there to run the Notepad, VLC, Media Player, Visual Studio. Every application or program you run, you open, there will be a process. How you can verify this? Now, if you right click on the taskbar and select a task manager, right, then it will open this one, right? And inside this one, you can see there is a button, process, performance, app history, startup, users, right? Details, services, all these things are there. And there is one fast button, you can consider process. And currently the number of applications I have opened on my machine, you can see I open Google Chrome, there is a process for Google Chrome, right? And this many number of window tabs I have opened, right? For Visual Studio, I have one process, right? For Microsoft Pro, I have one process, Notepad, Task Manager, Window Explorer, Zoom meetings, right? The number of applications I have opened on my machine, right? For each application, there is a process, right? And if you want to see what is the process ID, right, then you can go to the details section and you can check the process ID. For Google Chrome, the process ID is this one, right? So for each and every process, there will be a process ID associated with it. But apart from these processes, right, apart from this, what applications we are running, there are some other processes are also, those are called background processes, and these background processes are internally used by operating system to smoothly run your application. To smoothly run the operating system makes use of these background processes, right? And these background processes are needed and they are mandatory to smoothly run your application. So these are nothing but your application, what you are running on your machine, and these are nothing but your background processor, or you can say these are services which are concurrently running on your machine behind the scene, right? If these are not there, then you cannot properly use your operating system, right? So you can see these are the number of processes. Each application means one process is there, and you can see, so this is Microsoft Visual Studio, Notepad, Task Manager, Window Explorer, Zoom meeting. You can see everything is here, right? So you can see some of the applications are background processes, and some of the applications are, you can say, application. So everything you will find here, right? So these are the background processes and your foreground processes. Those are those processes which are running behind the application. They are called as background processes, and the applications which you are running, these are nothing but your foreground process. So what is all these things we are going to discuss? What is background thread? What is foreground thread? Right? What is thread? We are going to discuss. But for now, just remember, whenever you run any application, to run that application, operating system makes use of something called processes. So we have operating system, right? We have operating system. Under operating system, what we have? We have process. Under this process, what actually going to run? Under this process, our application or program is going to run. Understand this point or not?
Yes.
So
Yes.
you have application or program, right? You have operating system. But operating system makes use of something called process, and that process is responsible for executing the application, right? But here you will find that there are two types of a thread. One is, sorry, two types of process. One is what you are running as an application, and another one is background processes, right? The background processes are known as Windows services, and the operating system run a lot of Windows services in the background to smoothly operate your operating system, to smoothly work on your machine. These background processes are required, right? Without background processes, it is not possible to run all other applications. So we have an operating system. Under the operating system, we have processes that run our application. So the point that you need to remember is under the process application run. To run the code on to run the code of an application, the process internally make use of the concept called a thread. See, in this application means what? Now there are some code you have written. Yes or no? Yes. If you are creating one application, if you are creating one program, the program means behind the program or behind the application, you have written some code. If you are opening BL's media player, right? So this BL's media player is designed using a programming language only. If you are opening Google Chrome browser, it is also designed using a programming language. That means what? Everything what you are seeing behind the scene, there is only code. Without code, nothing is there, right? Then application of program means it is having some code, and this process internally uses something called a thread to run the application code. So what is thread? Now a thread is a unit of a process, and the thread is actually responsible for executing your application. See, operating system make use of a process to run your application, but process internally make use of something called a thread to run the application, right? Clear or not?
Yes, clear. Thank you.
Yeah. So generally, what is a thread? Generally, a thread is a lightweight process, means it is a unit of a process, or you can say it is a small part. A thread is a small part of a process, right? Or you can say a thread is a unit of a process, and that thread is responsible for executing the application code. So if you are saying process executing our application, that is fine. If you are saying thread running our application code, that is also fine, because this thread is not outside from the process. It is a part of the process. And this code is nothing but, it is nothing but your application or program code. And if you are saying operating system is running our application, then that is also fine, because from this operating system processes are there, right? And those processes are responsible for running our application code. But internally process makes use of something called thread, and that thread is actually going to run our application code, right? So every
to put it in a nutshell, we can call that operating system as a universal set, and all the other things are subsets of this.
exactly this operating source. See, in this case, this is one application, right? So in this case, one application, one process he allocate, right? So if you have another application, so application one, right? This is application one, let's say process one. This is application two, then operating system makes use of another process, right? And if you are having another application, right? So you have another process. Let's say application three is there, then process three will come into the picture. So the point that you need to remember, one process is not going to run multiple applications. One application means one process, right? That's what I'm showing now. You can see each process is having a different process ID. One process ID is going to allocate to one process, right?
And when you open one of those, for instance, if you open Google Chrome there on the left, if you open it, what are all those parts? Those are threads? I'm asking.
Yeah, exactly. Those are threads. So you can see in Google Chrome, I have opened multiple tabs, right? So for each tab, those are nothing but one part, right?
So one process
and you cannot
have many threads. One
you cannot
process
say,
can have many.
don't consider that these are threads, right? See, to run this Visual Studio, some exe file is required to be run, right? Those are nothing but things. Similarly, for Google Chrome, these are the things, right? And for Microsoft Word, these are the things. I'm opening one file, so that file is showing here. Notepad, I'm opening one file. So it is not like that. okay, these are threads, right? So basically this is what I'm opening, right? You can see task manager, Windows Explorer, right? Zoom meetings, right? So you can consider this is nothing but the number of tabs I have opened in my Google Chrome, right? For running this Visual Studio, these are the services which are required, right? And in this service, you can see this is the threading demo. This is the application that what I'm currently opening, right? So you can see this is the application and name, right? And coming to this Microsoft Word, this is the documentation name, right? What I'm opening currently, right? So this is nothing but LC. Threading and multi-threading are two different. So currently I'm creating this application threading demo. Currently one thread is running this application. It is also possible that multiple thread is going to run the same application. Don't consider that multiple Windows Chrome open means multiple multi-threading comes into the picture. Multi-threading is completely different. Currently one thread is going to run your application. So I'm not talking about multi-threading. Currently anything you can see, they are only single threaded. Only one thread is responsible for executing the application code. Because what? See, in this case, so this is one process only. One process is running your application code. By default, whenever you create a process, whenever you run any application, one thread is going to run your application code. It is possible that as a developer, we can make that multiple thread come into the picture and multiple thread is going to run our application code. That we will see later. But for now, don't consider that multiple tabs are open means it's multi-threaded. Only one thread is going to run your application, right?
Okay, thanks.
Yeah. So the point that you need to remember, every program or application has some logic, and to execute that logic or code, thread comes into the picture. See, in this case, application or program means what? Some code you have written, some logic you have written to execute those code and logic. This concept called thread comes into the picture, right? So by default, every process has at least one thread that is responsible for executing the application code. By default, right? By default, if you take any application, right, any process, by default, right, a single thread will come into the picture, and that thread is going to run your application code, right? Every process has at least one thread that is responsible for executing the application code, and that thread is called as your main thread, right? So the thread which is going to run your application, it is going to be your main thread, right? So by default, the process allocate a single thread to run your application code, and that thread is going to be called as your main thread, right? So main thread is responsible for executing your application code, right? And guys, in .NET framework, all the threading related applications, threading related classes are belongs to system.threading namespace, and as by default the process allocate a single thread to run our application code. So we can say by default, whenever we create a application, it is by default going to be a single threaded application. Why? Because a single thread is going to run our application code, right? So let us understand this thing, right? So in this example, right, in this example, I'm creating a simple program class having one main method, and inside that main method, I'm just creating one line of printing statement. And when I run this application, so guys, tell me how many threads are going to execute this application? Or first of all, tell me, does any thread come into the picture to run this application?
Yes.
Yes, you should get one thread, one console thread, I'm guessing.
Okay, so in this case, if you run this application, then you will see that exe is going to be available in our process, right? So that exe should be available here. So yeah, you can say this threading. So Visual Studio is running, that is separate thing, but now you are running your application. So this is nothing but your application which is currently running. And to run this application, first of all, it is loaded into the process, then it allocates some CPU, memory, all these things, then CPU is accessing this, right? And by default, as I mentioned, by default, every application is a single threaded application, right? Then what is happening here? Now here, so program execution is going to start from the main method, right? But to execute the application code, the process will come into the picture, right? then the process will allocate one thread to run our application code. So in this case, which thread is going to be allocated by the process? Which thread is going to be allocated by the process? Main thread only. The main thread is now responsible for executing our application code, right? And to see whether the main thread is actually running our application code or not, so what you can do, you just go to the debug, just select Windows, and then you will see something called a thread. Debug Windows, and there is an option called a thread. Click on this. Okay, so once you click on this, you will see that what is the process ID? Guys, tell me what is the process ID? My screen is visible to all of you. 540, right?
540.
Right now, come to the details section, right? And check, is there any process ID with the name 540?
Yes, there is.
And which EX is this one?
Threading
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 demo. That means if you go to this application, threading demo.exe should be there or not?
Yes. it is
This
there.
application is running by the operating system. One process is allocated. That process ID is nothing but your 540, right? So that is what you need to understand. And that process, the process allocate one thread, right? What is the name of the thread?
Main thread.
Main thread. And the location of from where this main thread start execution?
Program.
Threading demo.exe, this is your
Yeah.
exe file. Threading demo, this is nothing but your namespace. Program is the class name, main is the method, right? So this main thread is now responsible for executing this main method, where from where our program execution will start. Is that clear? So by default, whenever you create a application, this is going to be a single thread application. And to run any application, operating system makes use of something called process. Then process allocates one thread to run our application code. And by default, the process is going to allocate the thread, who is nothing but our main thread. And main thread is responsible for executing our application. Is that clear?
Yes.
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 Okay, fine. Now, so we have discussed, does the above program when run makes use of thread? Yes, by default that thread is going to be your main thread, right? And how you can check that, I have already given in the PPT, right? Now we need to understand, so this is what I can show you, but programmatically how I'm going to show you, right? Here I'm not showing the main thread programmatically. So here I'm going to show you by going to this debugger Windows, right? By using this process, right? I'm showing you the thread, but how I can show you this programmatically, right? So as I mentioned, all the threading related classes are belongs to which namespace?
System threading.
System.threading.
System.threading namespace. So we need to understand one class called the thread class. Okay, so for that, what I need to do is, first of all, I need to include the system.threading namespace. System.threading namespace, right? So once you include the system.threading namespace, there is a class called the thread, right? And if you go to the definition of this thread class, then you will see there are lots of properties, methods, right? Constructors. There you will find lots of things, right? And there is a property called current thread. And this current thread actually going to return me the thread currently executing, right? In this case, which thread executing your application code or main method, that thread information going to be provided by this current thread property, right? And as this current thread returning a property of which type? Thread type, right? And in this thread property, you can see there is a property called the name, which is going to get or set the currently executing thread name, right? So you have to remember two things here. One is current thread, which is going to return me the instance of the currently executing thread. Which thread currently executing your application code, that thread information is going to be provided by this property. So as it is a static property, right? So tell me how I can access this property. Do I need to create an instance of this class, or directly I can use the class name and dot current thread?
Class name.current.
because this is a class and this is a static property. And once I access this property, this is going to return me an instance of which class?
Thread class.
So on this thread class instance, can I access this name property?
Yes.
Yes.
Because this is a non-static property. If you want to access this property, you need to create an instance of this thread class. Yes or no?
Yes.
And this is a static property, so you can access this directly, right? But this static property, current thread going to return you one thread instance, right? And by using that thread instance, you can access this name property get and set. So, and you can see this is having a auto implemented property, having both get accessor as well as set accessor. That means using this property, you can set the currently executing thread name as well as you can get the currently executing thread name. So this is what I'm showing in this case, right? So let me copy this code. Right. See, by default, if you try to access this name property, right? By default, if you try to access the name property, then it will give you null. Okay. By default, if you try to access the name property, by default, it is not setting any name. So if you try to access programmatically the name property, then it is going to give you null. So let me run the application without setting the name property. You can see the output, the name is showing null, right? So if you want to set, first of all, you need to get the name property. So as you can see, the name property, if you go to the threading class, then you can see it is a property which is having both get accessor and set accessor. But the current thread, what you are saying, this is only a get accessor, right? So you cannot set that. So in this case, what I'm trying to do is, first of all, I'm accessing this current thread property using the thread class. It is a static property, so I'm accessing that property using the class name, and this property is going to return me an instance of which class?
Thread class.
That means I need to create a variable of a thread class to store that instance. So here I'm creating thread class variable and storing that instance which is going to be written by the current. So current thread, what it is going to return? It is going to return the currently executing thread instance. So which thread is currently executing this main method code? That thread information is going to return by this property. Then I'm setting the thread name for my internal use, and then I'm getting the thread name, right? So what you can see here, I'm setting the tree.name here, but here again I'm accessing this. See here I'm accessing t.name, so I'm getting the main thread. Even I'm directly accessing like this called thread.current thread.name. Even in this case also you will get the same name. Why? Because one thread is going to execute this application code, and once you thread a name to that thread, right? That thread name you are going to get by using these two approaches, right? Now let me run the application. See, main thread is running your application code. Any question from anyone? Any question from anyone?
Nope.
We need to set the thread name.
Say, so this is not required because what is the use of this thread name, right? In real-time application, we do not need to set any name for this one, right? Because there is no use of thread name, right? What I'm trying to make you understand is, now by default, one thread is going to run your application code, right? And that thread is going to be your main thread. And that thread here, I can set any name, right? So what I'm trying to make you understand is by default, one thread is going to execute your application code. And if you want to get the thread name or set the name thread, this is the process. Because whenever I'm going to create multiple threads, right, a multi-threading application, then at that case, at that time, I will make you understand that this is the thread name of your child thread 1, child thread 2, child thread 3, and this child thread 1 executing this method, child thread 2 executing this method. So at that time, it is easily for us to understand if you are setting the name, right? Otherwise, there is no use of this name property in your real-time application, and you will never see nobody is setting the name of your thread, right? This is for understanding purpose, right? right? So you can see in order to run our application code, one thread is created, that is the main thread. So this proves that by default, every application is a single threaded application, right? Now, what are the drawbacks of single threaded application in .NET framework? Okay. Right? Give me 1 minute, guys. Right? So guys, tell me now, in this case, I have created a main method and I have also created 3 different methods, method 1, method 2, method 3. Now, if I'm going to run this application, how many threads will come into the picture?
Single thread.
Only one thread. Only one thread, and that thread is going to responsible for executing this main method as well as responsible for executing method 2, method 1, and method 3. How the if it is a single thread, then the execution is sequential, right? The program execution is going to be sequentially if you are using a single thread. What it means? It means the program execution will start from main method. First, it will execute the method 1. Until and unless method 1 execution is not completed, it will not execute method 2. What it means? What means it will execute method 1. Once method 1 execution completed, it will come and execute method 2. Once method 2 execution completed, it will come and execute method 3. That means the execution is going to be sequential. It is not possible that method 1 execution starts, it is not completed, method 2 will start its executing. It's not possible. It's never possible. Until and unless this method execution not completed, you cannot execute this method. And until and unless this method execution not completed, you cannot execute this method, right? Until and unless this method execution not completed, this statement is never going to be executed. So this is nothing but your sequential execution of your application. And by default, every application what you created, they are going to be executed sequential, because that is going to be a single threaded application. Single threaded application means what? The sequential execution, right? Until and unless the method execution not completed, it will not execute the response. So you can see first method 1 start 1, 2, 3, 4, 5. So let me show you the code first. So the code is very simple. What I'm trying to do is I'm just looping through, right, from number 1 to 5 and printing the value, and I'm doing the same thing in each method. So I'm just writing a simple for loop which will loop for the 5 times, and it will just print the value of 1, 2, 3, and 4 and 5. It's a simple process, and that is what you can see. Method 1 execution started. Once method 1 execution started, method 2 execution start. Once method 2 execution completed, then only method 3 execution is going to start. And once method 3 completed, then only the main method execution is going to be completed. So this is nothing but your sequential execution, right? So in this case, what happened? The main thread first execute method 1, and once it completes the execution of a method 1, then it calls method 2 and then method 2. That means in this case, all these threads, all these methods are going to be executed by the main thread only. Is that clear? How the execution happening in a single threaded application?
Yes.
So
Yes.
single threaded application means the execution is going to be taken sequentially. Sequential means so once it will execute this method, then only it will execute this method. Until and unless this method execution not completed, it will not come to this one, right? Then what is the problem with the above program execution? Right. In our example, we are just writing some simple print statement to print the value from 1 to 5, right? What will you do if one method is taking more than expected time, right? Suppose in this case, okay, come to this method, and so in this case, the method execution, this program execution is fine, right? We're just writing small code inside the method, right? Which is not taking time, right? That is fine. But what will happen if one method takes more than expected time, right? So in this case, okay, let's assume that here, right? Here you are making some DB call, right? Here you are making some DB call, or you are making some API call, or you are making some web service call, right? So some heavy operation you are performing, which is taking more than expected time. Let's assume that this method 2 takes 5 seconds. 5 seconds. Then what will happen? Then this method 3 execution, this method 2 execution will be delayed by 5 seconds. Yes or no?
Yes.
That means this method 3 also going to wait for 5 seconds or not?
Yes, obviously.
Right? That means until and unless method 2 completes its execution, method 3 is never going to be started. Right? So in this case, we are doing some heavy operation. We are making a DB call, or we are making any API call, or we are making any Windows services call, right? Web services call. Then until and unless we are not getting the response from the database or from API or from web services, our method 2 execution is never going to be completed. It's not going to be completed, right? Until and unless method 2 execution is not going to be completed, we cannot execute method 3. That means here, so once we make the database call, right, for the 5 second or 10 second, okay, or whatever amount of time the API going to return me the output or database return me the output, that time I'm going to be ideal in my application or not?
Yes.
Right? So to
It will be ideal.
remove that, to overcome that problem, right? To overcome that problem, we need to go for multi-threading, right? So that once this method 2 taking more time, right? Once this method 2 is taking more time, don't wait for the method 2 to complete its execution. Let's continue with method 3. That is what the purpose of multi-threading, right? So what I'm going to do is, okay, let me give you the sample, right? So in this case, right, so this is my method 1. Method 1 is executing fine. Inside method 2, right, let's assuming that when for the third loop, I'm doing some database operation, performing the database operation. Okay, let's assume that we are making this operation to be sleep for 5 seconds. So what is this thread dot sleep means? It is a static method defined in the thread class, right? You can see this is a static method defined in the thread class. So as it is a static method defined in the thread class, so using the thread class name, you can call this method. And this that there are 2 overloaded version of the static method. One is taking time in time span, and another is taking integer milliseconds in timeout. So what is this method? We'll discuss later. But for now, I'm going to use this method. So here I'm passing the time in milliseconds, and that many number of seconds it will make the thread to sleep. So in this case, the thread which is executing our application code will sleep for 5 seconds, right? After 5 seconds, it will wake up and it will execute this application, right? That means here, which thread is going to execute our application code?
Main thread.
Main thread.
Main thread start execution method 1. Method 1 execution immediately completed. Then it will call this method 2. And in method 2, again, the same main thread is going to execute, right? This main thread is only responsible for executing this method. So in this case, this thread dot sleep will make this main thread to sleep for 5 seconds. That means this, if this main thread sleeps for 5 seconds, that means the main thread also executing our main method. That means it will not execute this code because this thread is already in sleeping mode. No further statement can be executed by this thread, right? So once after 5 seconds, right? After 5 seconds, the thread will wake up and it will execute the rest statement. And once it executes the rest statement, then once that method 2 execution completed, then it will come and execute the method 3, right? Now, so in this case, you will see the application is delayed, right, by 5 seconds. Okay, let me run the application code and show you the output. See, performing database operation started. Your application, your thread is slept for 5 seconds, and then it immediately complete the rest of the code, right? So that means what happened as we are running our application code, right? As we are running all the method using a single thread, because of the single threaded, we are facing this problem. What problem we are facing? Until and unless this method execution not completed, we are unable to run this code. We are unable to call this method, right? As this method execution is not completed, and the problem is that all the methods are going to be executed by a single thread only, and that thread is nothing but your main thread. Is that clear? What is the problem we are facing with the single thread application? So the single thread application means we are not utilizing the CPU resources properly, right? CPU allocating us the resources, but then we are making the CPU to sleep for 5 seconds. Actually, who is running the code? CPU only processing our application code, right? And that CPU is sit idle for 5 seconds. That means we are not properly utilizing the CPU resources, right? Then how we can overcome this problem? First of all, guys, you understand what is the problem?
Yes, sir.
Yes.
Okay, now the thing is that we need to understand how to overcome the problem, right? To overcome the above problem, we are provided the concept of multi-threading. As we already discussed, operating system has processes which is used to run our application. The process contains thread which will actually run our application code. A process by default makes use of a single thread to run our application code, right? A process by default makes use of a single thread to run our application code. That thread is nothing but your main thread, but a process can have multiple threads. But a process can have a multiple thread, and multiple thread can run our application code simultaneously, right? A process by default allocate one thread to run our application code, but a process can have a multiple thread, and multiple thread can also run our application code simultaneously. In this case, each thread, right? In this case, each thread is going to perform a different task, or you can say each thread is going to execute different part of our application code. Right? In our application, we have 3 methods. So 3 methods that we defined on in our application can be executed by 3 different threads. The advantage is that the execution takes place simultaneously. So when multiple threads try to execute the application code, then the operating system allocates some time period for each thread to execute. So what exactly we are trying to do? Currently, our program execution starts from the main thread. Even though if you are developing any multi-threaded application, the program execution is always going to start by the main thread only. Now, what I'm trying to do is, so process makes use, operating system allocate one process to run our application code. And that process allocate to one, in this case, you can see operating system allocate to one process, right, to execute our application code. And process by default makes use of a single thread to run our application code. But this process have the capability, this process has multiple threads, right? And if we are using multiple threads to run our application code, then this is nothing but your multi-threading, right? If you are allocating, if you are using multiple threads, right? Multiple thread means all those threads belongs to the same process only, right? And if you are using multiple threads to run your application code, then this is nothing but multi-threading. And if you are using multiple threads, then how the application code is going to be executed? Now, in that case, each thread is going to execute different parts of your application code. One thread is going to execute one part of our application code. Another thread is going to execute different part of our application code, right? So in that case, what operating system will do is, operating system is going to allocate some time period to each thread, right? So time period means what? Suppose in this case, suppose along with multiple thread, you created T1, thread 1, you created thread 2, you created thread 3. So in this case, it will allocate some time, some milliseconds to T1 to execute the code. If in that milliseconds the code execution is not completed, then it will allocate T2 to some time to execute the code, T3 to execute the code. That means the time period is divided, right? It will allocate some time to T1, it will allocate some time to T2, it will allocate some time to T3. what time it allocates to T1. If within that time period T1 not completes its execution, then it will not wait for the T1 time, T1 thread to complete its execution. It will simultaneously ask T2 thread to start its execution. If T2 thread not completes its execution within the time period what allocated to him, then T3 again come to picture, and then T3 will start its execution. Right? If T3 not completed, again T1, again T2, again T3. In that way, multiple threads are going to be run simultaneously. Right? Is that clear?
Yes.
Right. Right.
Yes.
Okay.
Yes.
So if all these threads are going to be run simultaneously, then guys tell me the output is going to be in a sequential order or it is in a random order.
Random.
Random.
Obviously
Random.
random
Random
order, because if T1 method is going to execute method 1, T2 is going to execute method 2, and the T3 is going to execute method 3, right? So on this, if this T1 thread not completed the execution, then T2 thread immediately start. Now it will not wait T1 thread to complete its execution. But the point that you need to remember is at any particular given point of time, only one thread is going to execute your application code. Right? And to the time what allocate to that thread, if that thread not completed its execution, then other thread come into the picture will start execution. That is the whole agenda of multi-threading. Don't consider that all these three threads are going to be executed at the same time. They are going to be executed simultaneously and the same time. Both are two different things, right? Simultaneously means what? One another, one after another, one after another. At the same time means all these three threads are going to be executed at the same time. This is not possible. This is the wrong syntax, the wrong information, right? So is that clear?
I have
So
one
doubt.
question.
Yeah, ask me.
Yeah. When this is getting executed, method 1, method 2, method 3 with some kind of time period.
Yes.
So it will be like a piecemeal, like here some kind of process executed, then second method, some executed, third method, and again, what is that? Iteration takes place, right? Several iterations takes place, right?
So several iteration means, say in this case, see, if you want to execute, then CPU is going to process our code, right? Processing happens through only CPU only, right? You can say. So anything you want to execute that will be taken care by the CPU in our system, right? So in this case, if you are creating 3 threads, right? 3 threads means as part of the single process only. Including main thread, the number of thread is going to be 4 in this case, right? If you are creating 3 custom threads and including main thread, the total number of thread is going to be 4. So in this case, the CPU will allocate some time period to each thread. It will allocate some time to main thread. It will allocate to some time period to, so let's assume it allocate 200 milliseconds to T1, 200 milliseconds to T2, 200 milliseconds to T3, right? So it will start execution from T1. See, from which thread the execution is going to start, we cannot give guarantee, right? So that will be taken care by the CPU. So T1 execution start within 200 millisecond execution not completed. It will move to the other thread. Other thread will start its execution within the 200 millisecond not completed. It will go to the other thread. Within that 200 millisecond, T3 thread completes its execution. That is fine. Now 2 threads are pending, right? Their execution. Then again it will start execution T1, again T2. So once the execution completed by one thread, that will be done. Right? So the time period of how many time period to allocate to which thread, that we cannot control, right? That is going to be controlled by the central processing unit. CPU will allocate some time slash, some time period to each of these threads.
Okay, then all the methods will execute at the same time, but
No,
according to
no.
the thread timing, it will the
Yes,
output
yes.
will be executed.
Yeah, I'm saying that 2 things here. One is simultaneously and another is same time. So this is the point you need to remember. Simultaneously means what? T1 method start execution. It is not completed its execution. T2 thread start execution. T2 thread start not completing its execution. T3 start its execution. This is nothing but your simultaneously. Same time means is all these threads T1, T2, and T3 are going to execute at the same time. If they are executing at the same time means that is same time. But in this case, in multi-threading, these three threads are never going to be executed at the same time. At a particular given point of time, only one thread is going to be executed, right? And for that thread, the CPU will allocate some time period. Within that time period, if that thread completes its execution, that is fine. If not completed, it will move and execute the other thread. That is nothing but your simultaneous.
Yeah, okay. Thread is okay. I am talking about the methods.
Yeah.
Methods will run at the same time. Then
See,
one by one.
See, what is the role of a T1 thread? T1 thread is going to execute method 1. T2 thread is going to execute method 3. T3 thread is going to execute method 3. Sorry, T1 method 1, T2 method 2, T3
Okay.
method 3. If these threads are not executing at the same time, then how the method are going to be executed same time? Because these threads are responsible for executing the method. Huh?
Okay. I thought the T1, T2, T3 in the same thread,
No,
same
these
method.
are
Okay, fine.
These are different threads, and each thread is going to execute a different code. Okay, so let me give you with practical. Okay, so in this case, you can see this is my method 2, right? This is my method 3, and this is my method 1, right? And you can see I'm using this property thread.currentThread.name. So what this property is going to return me? The currently executing thread name. So which thread executing this method 1, that thread name it is going to print here, right? And when this method execution end, again I'm printing the name of the thread. And in this case, which thread is executing this method 2, that thread name is going to print it here. And in this thread, I'm delaying this execution for 10 seconds, right? I'm delaying this method 2 execution for 10 seconds. And again, here I'm also printing the thread which is executing this method 2. And here I'm doing the same thing. Which thread executing method 3 when started and when ended, that thread name I'm printing here, right? Now we have 3 methods, right? Now we have 3 methods, and now to execute these 3 methods, I'm going to create, see, three threads. First of all, this main method, it is always going to be executed by the main thread, right? Now, how to create a thread, right? We are going to discuss this thread class in detail in our next session, right? But for now, how to create a thread means you need to use this one. So the way you create an instance, right? The way you create an instance of a delegate, in the same way you need to use the thread class. So to the constructor of a delegate, what you need to pass? Guys, tell me.
Method we want to execute.
So the same way to the constructor of thread class, you need to pass the method name which you want to execute. Clear? Why I'm passing the method name, right? That we will discuss detail in our next session, right? If you go to the constructor, this thread class taking one parameter of thread start. What is this thread start? If you go to the definition, then you will see that it's a delegate. And we know what is delegate. Delegate means what? Now delegates are basically used to execute method, right? So this is the reason why we are passing this method name directly and it is accepting, right? How all these things we will discuss tomorrow, right? But for now, this is how you need to create a thread instance. Thread class instance means through the thread class constructor, you need to pass the method name which you want to execute by that thread. And here, and in this thread class, if you will see, there is a property called a name, right? This is the name property. So this class having one property. So what I'm trying to do, I'm providing this name as thread 1. So this thread class providing the name as thread 1, and this thread T1 pointing to method 1. That means when I invoke this T1 thread, then this method 1 is going to be executed. Is that clear?
Yes.
Right. And I'm doing the same thing with T2 and T3. This is thread 2, which is going to execute my method 2. This is T3, which is going to execute my method 3. Right. And in this case, in previously, how to invoke the delegate? You need to invoke the delegate like a method, or you need to invoke the delegate by using the invoke function. But in this case thread, you need to invoke the thread by using the start method. So here you are just creating the thread, right? But if until and unless you doesn't unless you do not start the thread, the method is never going to be executed. So in this case, once you call this t1.start method, then this T1 thread start executing, and this T1 start pointing to this method 1. That means the method 1 body is going to execute. And once you call this T2, then the method 2 is going to execute. And once you call this T3, then the method 3 is going to execute, right? So in this case, I'm creating like this, right? So any question from this implementation?
No, it appears.
Right, guys, one more thing. Who created this thread, T1?
We have created.
We have created means who exactly? Who executed this main method?
Main thread.
Main thread. That means this T1 thread is going to be created by the main thread only. T2 thread is also going to be created by the main thread. T3 thread is going to be also created by the main thread. So here, the main thread is your main thread, and the other threads which are created by the main thread, they are called as a worker thread, or you can say child thread, right? So going further, we'll discuss lots of things related to this child thread. So suppose you want that until and unless my child thread not completes its execution, I do not want to complete the main thread execution. Here, if you want that until and unless this T2 thread not completes execution, I do not want to execute this T3 thread. That is also possible. All these things we are going to discuss. We are going to cover, right? So, but for now, just remember the main thread is always responsible for creating the child thread, right? And in this case, in method 1, if you are going to create some other thread, then that thread is going to be created by T1 thread. So in that case, the other thread is going to be a child thread of T1 thread. So in this case, T1, T2, T3 are nothing but a child thread of your main thread, right? Now, let me run the application. And in this case, you will not find this output in a sequential manner, right? See the output. Database operation started, and here we are delaying the execution. Execution delay for 10 seconds, then the other things are going to be executed. And you can see the program execution. So method 1 started. Method 1 started using thread 1. So it is executing the loop 3 times. Method 1, method 2, 3. Then again, you can see method 3 started using thread 3. Method 2 started using thread 2, right? So method 2, then performing database operation started, method 1. So the thing is that you need to remember, you cannot predict the output. Every time you run the application, you will get a different output. And that is acceptable. Why? Because the methods are not going to be executed sequentially, right? As they are executed simultaneously, so this type of output we can predict. Is that clear?
It will be problem, right? If methods are dependent on each other.
Exactly. That is what I'm going to tell you. See, if all these 3 methods are independent means if they are not related to each other, then you need to use in multi-threading. But if you want, so if you have one scenario where you want the output of one method as an input to other method, then you can, in that scenario, you cannot implement this multi-threading, right? For example, if your requirement is that once this method execution completed, right, then only I need to execute that method, right? If that method executes, otherwise it's scenario like this. If these 2 methods are completed, then only I need to execute this T3 method, right? That is also possible. That is what I'm showing previously. That is also possible. If you want these 2 method execution completed, then only I need to invoke this method. That is also possible. How? That we will see in our upcoming sessions, right? And if other, so in the case of multi-threading, so that is possible. So the output you cannot predict in which manner the methods are going to be executed. But if you still want to provide some sequential execution, right? If you want, you can make this thread to delay here, right? If you want, you can make this thread 1 to complete its execution, then only execute T2. Then once T2 thread completes the execution, then only execute to T3. If that is your intention, that if you want to execute the methods sequentially, then why you should go for multi-threading? Right? If you want to execute the method sequentially one after another, then in that sense, does it make sense to create multiple threads? Because creating thread is also going to take time. Na? Even though if you want to execute these 3 methods sequentially, right, then it doesn't make sense to create multiple threads. Right? So when you will go for multi-threading, if the methods are independent, they are not dependent on each other. If there is no issue at all, if I'm executing multiple threads sequentially, then only you need to go for multi-threading. Clear?
Yes.
So one question, please. So if we extend this concept, it means that the operating system is only doing one thing at a time. I mean,
Yes.
but he rotates so fast that it seems that he's doing many things at the same time, but it's
Right.
only doing one process at a time. I am asking.
See, operating system having different things. See, operating system provide the this application to run by one process. You can run multiple applications at the same time, right? So this is application 1. You are opening Visual Studio. You are opening in Notepad. You are opening Microsoft Word document, right? These are nothing but one application, and operating system allocate some process to run this application at the same time. See, operating system provide this process and provide this process 2 to application 2, process 3 to application 3, and all these 3 applications can run simultaneously at the same time. At the same time, you can download something from internet. At the same time, you can watch, you can listen a song using Windows Media Player. At the same time, you can also type something on the notepad. Multiple application can work at the same time, but multi-threading concept comes into picture whenever you want to run the application code by using multiple threads. Right? In this case, multi-threading doesn't mean running multiple applications. Multi-threading means running a single application by using multiple threads. And in that case, the CPU will allocate, CPU will distribute the time period to all these threads. So suppose this is there are 4 threads to run this application code, then CPU will decide, okay, let me give 200 milliseconds to T1 thread, let me give 200 milliseconds to T2, let me give 300 milliseconds to T3 threads, right? And in that way, if that thread is not completed its task, let's move to the other thread. Within that time period, if the thread completes the execution, then no worry, just go and execute the other threads. Right? And how many times to allocate to which threads and what is the order of executing the thread, that we cannot predict. That is going to be decided by the CPU only. Clear?
No, T1 is on application, T2 is on T3 is on application.
So here T1 and T2, they are not application, they are threads.
Application. I mean, application is thread. Like
no,
application 1 thread.
Application is not a thread. Application is an application. To run that application, we use threads.
Yeah, that only. It is T1 is thread for application 1, and yeah, T2 is thread for application 2.
You are getting confused. Let me explain in this way. So currently you are running 3 applications. What are these? Media Player, Notepad, and MS Word, right? So for this VLC Media Player, you have one process, right? In this process, you are having 4 threads, right? For process 2, you are having TH1, TH2, only 2 threads, right? And for process 3, you are having this one, right? So this thread, what even you can create like this. This T1 thread, right? This T1 thread is not same as this T1 thread. This T1 thread is created by the main thread, which is comes under this process 3. This T1 thread is created by the main thread, which is under this process 1. This T1 thread is only responsible for executing this application code. This thread cannot execute this application code because the process ID, what you are using here to execute this media player, is not same as the process ID executing this notepad. If you remember, I show you from the beginning, each application what you are running, they are provided with a different process ID, right? And that process ID is not same here. Suppose the process ID here, you are providing 540, then you cannot see this 540 process ID here and here. The process ID is going to be unique and they are going to be different like this, right? So these are thread. You are creating this thread to run this application only. You cannot use this thread to run a different application. And you cannot use this thread to run another application. Right? Understand or still doubt?
Okay, Pranay. Cool.
Got it now? So you just remember, this is your application. To run this application, this process 1 is there. And this process 1 now creating multiple threads to run the application. And this thread, you cannot use this thread to run a different application because the process ID to run this application is different than the process ID what running other applications. Right? Guys, any question from anyone?
Suppose one question, like if we are serving one request, like suppose one thread is doing one work, and there will be no chance that it will leave that job at middle and it will switch to another thread. No, it will not be the case, no? Because you're telling that specific time will be allocated to each thread. If the work is not completed in that time, it will go to another thread.
Right.
So if our thread
it will continue like this until the thread completes its execution. So it will switch between the threads until and unless the thread completes its execution. Once the thread completes that task, that thread will not come into the picture again, right? That is what you need to understand. Once the T2 thread completes its execution, and if T1 and T3 are not completed, then once T2 completed, then the time will be switched between T1 and T3 only. And if T3 then completed, then the rest of the time it will wait till that thread T1 is going to complete its execution.
No, I'm not talking about full completion, but suppose the part of the completion. Suppose in thread, if you go to our example, in that we have different tasks, like we are printing from, suppose we are printing from 1 to 10. Okay. So in that case, suppose thread 1 printed 1, 2, 3, or suppose thread 1 is printing 1. Unless it is printing 1, it will not switch to other thread, right? At least part of the the main task that is allocated for thread 1, it will finish that and it will switch to other thread. It will not switch according to the timing. If that thread part of the task is not completed in the specified allocated time, it will not switch directly to other thread in between.
Then why you are going for multi-threading in that case? If you don't want, see, in this case, the thread T1 thread, it doesn't know what is happening within the code block, right? T1 thread know what is, I'm going to execute this method, right? So T1 thread is going to execute this method. So what you are saying, that is inter-thread communication concept, right? Inter-thread communication means I'm having 2 different threads, right? Unless I'm not executing this thing, you cannot continue your execution, right? Once I'm completing this statement, once I'm printing 1 to 3, then only you just go and execute the thread, right? So that is nothing but the concept of inter-thread communication. 2 threads can communicate with each other. He will start executing and he will signal the other thread to start your execution, right? That is the different story altogether that we are also going to discuss, that concept inter-thread communication. So in this case, this thread will execution, and when the I value become 3, then only the other thread is going to start its execution. That is what you are asking, right?
Yes, yeah, part of the
Yeah.
execution is when it is.
Yeah, so that is possible. That is possible. That concept we are also going to discuss. That is inter-thread communication. So when I value becomes so once this statement printed for I value 3, then only I need to execute this thread. That is possible. That we are also going to discuss. That is a concept called inter-thread communication.
Can you please execute this one? So, need to check the out.
Every time you run the application, you might get a different output.
Yeah.
See,
Okay, fine. Thank you.
every time you run the application, you will get the output, right? Now, what I'm trying to show you, I'm just opening Windows in this thread. So currently the execution completed. Okay. Debug Windows thread. Right. So currently you can see this is thread 1. It is a worker thread, and this is main thread. This is nothing but your main thread, right? Okay. So let me put some to give you better clarity. What I'm going to do is I'm going to put the debugger point here, the debugger point here, and the debugger point here, right? You can see currently how many threads running your application?
4 threads.
So one is main thread, right? And other are nothing but your worker thread, or you can say child thread, right? So main thread is responsible for executing the main method from where the program execution starts. You can see main, right? So there are main thread and worker thread. Worker thread is nothing but your child thread, and main thread is nothing but your main thread, which is responsible for start the execution of your application. Right. So what is multi-threading? Right? If multiple threads are used to execute your application code, then it is called multi-threading. Multi-threading is a mechanism to implement concurrent programming where multiple threads operate simultaneously. Simultaneously means one after another. One after another means they will not wait till the thread 1 completes its execution. On the time period what allocates to one thread, if that in that time period the thread not completes its execution, then other thread will come and start executing. The main advantage of using multi-threading is maximum utilization of CPU resources, right? So in this case, the CPU is not going to be ideal, right? In previous example, what we say, now once the thread sleep, then the CPU is sleep, right? In this case, once the thread, if one of the thread is going in the sleeping mode, right, then other threads are not going into the sleeping mode. They will continue their execution. This is the biggest or the main advantages of using multi-threading. So what is thread class? You can see in this example, we are using some concept called a thread class. So the thread class is used to create a thread. So in this case, you can see this thread class is used to create a threads, right? With the help of a thread class, we can create foreground and background threads, right? What are foreground, background threads? That we are going to discuss in our comment session. Thread class also allows us to set the priority of a thread. Priority of a thread means if you are having multiple threads, then you can set the priority, and that thread priority will come into the picture when we will discuss deadlock, right? In deadlock means what? Multiple threads are there, and when deadlock occur among the two threads, one we need to choose as the victim thread so that the execution of that thread is going to be cancelled. Then how will set that whose thread to be get cancelled? Right? At that time, the thread priority comes into the picture. That we are also going to discuss, right? The thread class also provide a current state of a thread, right? In multi-threading, right? The thread having different states, right? So what is the current state, right? That we will also discuss when we will discuss the life cycle of a thread. The thread class is a sealed class, so it cannot be inherited. So you cannot create a child class by inheriting from the thread class. Why? Because it is marked as sealed. And we already discussed, right, the concept of sealed class and sealed method. By default, when you create a method, that is a sealed method, and that method cannot be overridden in the child classes. If you want to override, then you have to make that method as virtual, right? And similarly, if you mark any class as sealed, then that class cannot be used as a parent class for other classes, right? That means further inheritance is not possible. So these are the points. And in our next video, we are going to discuss the thread class in detail. Thread class means how this is possible, how if I am passing this method and how that method is going to be executed. So all these things we are going to discuss. Basically, we are going to discuss these 4 things. What is this thread start, parameterized thread start? All these things we are going to discuss in detail, right? So anyone having any question related to today's session, they can ask me now.
And Pranay, what if we use for delegates? It will go in a sequence order. Like if you use multi delegates, like D4 equal to D1 plus D2 plus D3. Then if we use in threads, it will be like whenever according to the time. It will not
Just tell me, if there is, if
Okay.
you are creating a delegate and if you are attaching only one method, that is going to be executed that method, or is there any sequence comes into the picture?
No, it will no sequence comes into the picture.
In this case, how many methods you are registering with the thread?
3 to 4 methods. I mean
How many?
multiple.
This is one thread only, na? This is a different
Yes.
thread. This is a different thread, and you are registering only one method to this thread. That means when this thread start, this method is going to execute. There is no relation between this T1 and a T2. This is a different thread altogether.
Okay.
This is T1 thread and this is C. If you are creating 2 delegates, one delegate pointing to method 1 and another delegate pointing to method 2, and if you invoke delegate 1 dot invoke, and if you execute delegate 2 dot invoke, both are going to be executed or not?
Yes.
The sequence will come into picture when you registered multiple methods to a delegate.
Yeah.
Right? And if you are registering a single delegate, if your delegate is pointing to a single method, then that method is going to be executed. There is the order will not come into the picture.
Okay. Okay.
Got it? So in this
Yeah,
case,
got.
yeah, we are not registering multiple methods so that the sequence will come into the picture. We are only registering a single method. And here, don't confuse T1, T2. They are a different thread altogether.
Okay. Okay. Thanks.
Okay. Any question from anyone else?
Yes, sir.
Yeah, ask me. Okay.
Sir, is there any instance that the system itself is creating the multiple threads for its use, or we need to specifically tell the system to use multiple threading? Is it explicit?
So here we are explicitly telling the system to use multiple thread by creating multiple thread in your application, and by invoking that start method, we are explicitly telling the system to implement or use multi-threading. If you are not creating the thread class and if you are not invoking the start method, then multi-thread will not come into the picture.
Okay.
This is explicitly here we are only explicitly creating the thread now. Implicitly only one thread is there, that is main thread. Explicitly you can create any number of threads.
So internally, program will not create multiple threads on its own. We have to tell it to create.
Yeah, that is what I'm showing in the beginning. Now, by default, whenever you create a application, that application is going to be a single thread application. Why? Now, because by default, the system will create, the process will allocate one thread, right? By default, the process will allocate one thread, and that is the main thread, and that main thread is going to execute your application code. If you want to implement multi-thread, then it is a developer responsibility. It is programmer responsibility to implement multi-thread, right? Multiple thread is not going to be provided by the process. Process will allocate only a single thread. If you want a multiple thread, then you have to implement this in your program. Any more question from anyone?
No, sir.
Okay. And guys, please do practices, right? Whatever I'm showing you, right? You will not find anywhere, right? So nobody is going to show you that debug, right? They do not know that there is an option called Windows debug and this thread option, right? Where you can see the worker thread and where you can see the main thread, right? And nobody is going to show you these things, right? There is a process, right? Inside the application, each process, each application is associated with the process, and each process having a unique ID. That ID you can get it from here, right? These things you will never find from anywhere or from anybody, right? Because these things are coming into the picture when only you are going to work, right? Sometimes what happens, now you run one application, right? And that application is not stopped, and you want to kill that application. How you will do? Suppose you are running one Windows service, right? And some point of time that Windows service is not stopped. Then how you are going to stop that service? Suppose, okay, let me come to this part. Okay, let me, yeah, threading demo.exe is one application is currently running. Let's assume that you are unable to close this or stop this application. Then how you will do this? Is there any other approach? Yes, there is other approach. How? So what you need to do is, what is the name? Name of the application is threading demo, right? So you just go to T, where it's T. Okay, threading demo.exe, right? So you just click on this and select go to services, right? End task, process time, right? You can see multiple options are there. So you just need to click on this end task, right? So once you click on the end process, you will see that that application what currently running, that is going to be deleted. And this will, you will able to know, and these things you will come to know only when you are working, right? Any working professional, they are having good experience, they know these things, right? Any freshers, any trainer who are providing training, they do not have any real-time experience, they do not know these things, right? They even do not know that how these programs are executing by CPU, right? There is a process associated with application what we are running. They do not know these things, right? So please do practices, try to observe the things by your own so that you will get more clarity, right? So if you check this one notepad, so you can go to the properties and you will see what is this. So this notepad is this one, and this location where this is created, right? Everything you will get from the process. So how many files you are opened, all this will come into the list. Currently, I'm opening one file, notepad file, and this file doesn't have any, what you can say, name. So you can say on title, right? And already I have shown you in the beginning, there is something called the data files and program files. Program files are basically to run your application, right? If you want to use notepad, right? So notepad should be loaded into the CPU, right? So once the notepad is loaded into the RAM, then only you can create your data file. Data file is nothing but the actual file where you are going to store the data. So this is nothing but your data file. But in order to work with the data file, your application file should be loaded into the CPU and into the RAM, and so that CPU can access it, right? And you can see the how many space is allocated to that application, right? All these things you can see here. What is the memory allocation? How many bytes of memory is allocated for that application? Everything you can see. And sometimes you can say it is very high. Zoom meeting is very high because it is running from last 2 hours. And you can see Google Chrome is also very high, right? So memory utilization, right? So you can see the memory utilization, it is taking 500 MB. And for power usage, most of the power of battery is going to be consumed by this Zoom meeting, right? So you have to understand these things sometime, right? Because whenever you are working with your real-time application, right?
sometimes you will see that your application becomes very slow, right? Loading the page taking more time, or getting the API response taking more time. Then what you need to do, you need to go to your server where your application is hosted. Then you need to go to the Windows Task Manager, and then you need to check how much CPU utilization is there, how many memory utilize, how many percentage of memory utilization is there, right? Then you need to, then you will come to know that yes, CPU utilization is more than 80 or 90%. That means something is happening, right? Then you can see who are the user logging into your server. All these things you can see. Currently, you can see in this server I'm using, and I'm logging all these things. So at that time, you can do what thing, you can delete the unnecessary user, right? So you can close, disconnect the user who is connecting to your server. So these are the things you need to do when you are working with real-time applications, right? So please try to do these things and try to practice the program as much as possible, and don't stop here, right? Whatever documentation I am providing, that is more than enough. But one thing is that nobody knows 100%, right? It might be possible that whatever I'm explaining, I might be missing something, right? Some other trainer or some other website articles, right? They might be giving you some more information, some other information which might not be provided by me, right? So don't stop here by looking at my documents, right? Try to learn something new from others, right? Other means in the sense, try to search the same concept in Google, right? And you will get lots of articles related to that concept, and just go through it and just check if anything is missing. If missing, then you need to capture that, right? Don't stop by looking at my documents only. Try to learn, try to enhance your capability, enhance your skill by looking at others also, right? Because nobody is in the world is perfect, or no one can give you guarantee that he knows everything, right? Even today, I'm also learning C#, right? Because C# is that use. If someone saying that I know everything about any programming language, that means he is saying blindly or he is a mad person. Nobody, even the person who developed Microsoft, right? The person who are working, or the community who are enhancing the code in Microsoft, even they do not know 100% about the C#.NET language, right? So that is the thing that you need to remember, right? So try to learn something new every day. And yes, whatever I'm providing, that is more than enough, but not 100%, right? Not 100% means something is there which I might miss, which I might not know, right? In that case, you have to go through the website and you need to check the things, right? If everything is available in our document, then that is well and fine. If something is missing, then you need to get that something from other side, right? And another thing is that if you learn that thing, then please share in the group so that other people will also come to know any new concept which we might miss, right? Any good example, right? Any better article link, you know that this link is giving you better better concept, right? Then you can also provide that link in the group so that other person or other people will get benefit from that. Any YouTube video you find it useful, then you can also provide the link so that other people can watch that video, right? So in this way, what happened? Sharing means once you share, then other will get benefit. Clear? Guys?
Yes.
Okay. Okay. So that's it for today. We'll see tomorrow.
Yeah. Thank you, sir.
Yeah. Well.
Thank you, sir.